In mathematics, a composition algebra A over a field K is a not necessarily associative algebra over K together with a non-degenerate quadratic form N which satisfies, for all x and y in A.Unital composition algebras are called Hurwitz algebras. If the ground field K is the field of real numbers and N is positive definite, then A is called an Euclidean Hurwitz algebra. The quadratic form N is often referred to as a norm on A. Composition algebras are also called normed algebras. These should not be confused with associative normed algebras, which include Banach algebras. Although three associative Euclidean Hurwitz algebras R, C, and H in fact are Banach algebras. Structural theorem. Every unital composition algebra over a field K can be obtained by repeated application of the Cayley-Dickson construction starting from K or a two-dimensional composition subalgebra equals 2. The possible dimensions of a composition algebra are 1, 2, 4, and 8. One-dimensional composition algebras only exist when Char-2. Composition algebras of dimension 1 and 2 are commutative and associative. Composition algebras of dimension 2 are either quadratic field extensions of K or isomorphic to KK. Composition algebras of dimension 4 are called quaternion algebras. They are associative but not commutative. Composition algebras of dimension 8 are called octonion algebras. They are neither associative nor commutative. The case Char-2. Scalar product. If K has characteristic not equal to 2, then a bilinear form equals 1/2, n minus n is associated with the quadratic form n. Involution in Hurwitz algebras. Assuming A has a multiplicative unity, define involution and right and left multiplication operators by evidently as an involution and preserves the quadratic form. The overline notation stresses the fact that complex and quaternion conjugation are partial cases of it. These operators have the following properties. The involution is an anti-automorphism, i.e., AB equals BA, AA equals N1 equals AA, L equals L asterisk, R equals R asterisk, where asterisk denotes the adjoint operator with respect to the form. Re equals Re where Re x equals 2 equals Re c equals Re. L equals L2, R equals R2, so that A is an alternating algebra. These properties are proved starting from polarized version of the identity equals. Setting B equals 1 or D equals 1 yields L equals L asterisk and R equals R asterisk. Hence Re equals Re. Similarly equals C equals. Hence Rec equals C, 1 equals 1 equals Re. By the polarized identity N equals so LL equals N. Applied to 1 this gives AA equals N. Replacing a by gives the other identity. Substituting the formula for A in LL equals L gives L2 equals L. Para-Hurwitz algebra. Another operation may be defined in a Hurwitz algebra as xy equals xy. The algebra is a composition algebra not generally unital, known as a para-Hurwitz algebra. In dimensions 4 and 8 these are para-quaternion and para-octonion algebras. A para-Hurwitz algebra satisfies conversely. An algebra with a non-degenerate symmetric bilinear form satisfying this equation is either a para-Hurwitz algebra or an 8-dimensional pseudo-octonion algebra. Similarly, a flexible algebra satisfying is either a Hurwitz algebra, a para-Hurwitz algebra or an 8-dimensional pseudo-octonion algebra. Euclidean Hurwitz algebras. If the underlying coefficient field of a Hurwitz algebra is the rails and Q is positive definite, so that equals 1/2 Q minus Q is an inner product, then A is called a Euclidean Hurwitz algebra. The Euclidean Hurwitz algebras are precisely the real numbers, the complex numbers, the quaternions and the octonions. Instances and usage. When the field K is taken to be complex numbers C, then the four composition algebras over C are C itself. The direct sum CC, known first as tessarines, the 2 times 2 complex matrix ring M, and the complex octonions CO. Matrix ring M has long been an object of interest, first as biquaternions by Hamilton, later in the isomorphic matrix form, and especially as Pauli algebra. Complex octonions have been used in a model of angular momentum. The squaring function n equals x2 on the real number field forms the primordial composition algebra. When the field K is taken to be real numbers R, then there are just 6 other real composition algebras. In 2, 4, and 8 dimensions there are both a split algebra and a division algebra. Complex numbers and split complex numbers, quaternions and split quaternions, octonions and split octonions.